Geez, Angeline, I'm failing chem right now. Can you help me?
Sure, what do you need help on?
Do you know what the CESPR is?
Hey, do you mean the valence shell electron pair repulsion model? I know what that is. According to the textbook, the Vesper model is based on the idea that electron domains are negatively charged and therefore repel one another. The best arrangement of a given number of electron domains is one that minimizes the repulsions among them. Make sense?
No. But I wasn't even talking to you.
Basically, the Vesper model is the idea that electrons have a tendency to stay away from each other. Consider this example. If you have two identical balloons and you tie them together, they will face opposite directions and stay far away from each other as possible. This is a linear shape.
Right. And if you tie three balloons together, it will form a triangular shape because that is the furthest away that they can get from each other. It's important to note that although the Vesper model can predict different molecular geometries, it does not explain why bonds exist between them.
Wait, what is the connection between the valence bond theory and Vesper?
Basically, the Vesper model provides a general explanation for the electron domain geometry, while the valence bond theory explains the reasoning for the different exceptions to the electron domain geometries. It's basically because they form hybrid orbitals. S and p orbitals form an sp orbital, which is neither the shape of a solely an s orbital or solely a p orbital. Essentially, it's a hybrid, which accounts for the different geometries that go unexplained in Vesper.
Huh, that makes sense. So, what's the difference between electron domain geometry and the shape of the molecule? I know it has something to do with electron domains, but I don't really know what that is.
The shape or molecular geometry is dependent on only the atoms of a molecule, while the electron domain geometry relies on the number of both the bonding and non-bonding pairs of the molecule. You can determine the shape of the molecule using the Vesper model. The molecular geometry, or 3D geometry, is responsible for different physical and chemical properties. Therefore, Vesper explains properties such as the melting point and solubility. However, it cannot explain diamagnetism and paramagnetism.
In case you didn't know, a single electron domain around the central atom of a molecule is constituted as one non-bonding pair, single bond or multiple bond. A non-bonding pair defines an electron domain that is located on one atom, while a bonding pair occurs between two atoms.
So, what are the different molecular and electron geometries?
Here's a chart to help you learn about that.